You'll hopefully remember that there are two types of logical reasoning, two major types. The first one is called inductive reasoning, or simply induction, and inductive reasoning will give us what we can call induced facts as opposed to empirical facts. Empirical facts come to us straight through the senses. Induced facts are facts that we have to interpret using inductive reasoning. So remember, the way inductive reasoning works is that we observe the same phenomenon multiple times, we observe carefully how it happens, and then we draw the general conclusion from that that phenomenon will always behave the way we've observed it to behave many, many times. In science, this gives us laws or constants, which are fairly limited in induced facts, in the sense that, for example, the law of electrical charges, that opposite charges attract, is kind of a limited idea about the universe because all it tells us is what opposite charges do. It doesn't give us like a really big picture of the universe. But it does extend our senses by allowing us to know things, or at least to have good reason for thinking that we know things that we haven't actually observed. We call that extrapolation, where we take the data we've observed and we analyze it with inductive reasoning, and we go beyond it, we extrapolate. The problem with inductive reasoning is that it does give us reasons to believe things about the universe, but it never gives us 100% certainty or absolute certainty. To have absolute certainty, to know that this will always happen, we'd have to observe every time that phenomenon has ever happened, is happening right now, and ever will happen. That's the only way. Otherwise, we can't ever be sure that, well, because something happened this way the last 20 times means that it won't happen differently the 21st time or the 21,000th time. Okay? The solution to that is that we can never get 100% certainty with inductive reasoning, but we can get closer and closer to that by making more and more observations. The more times we observe a phenomenon, the more certainty we have that this will always happen that way. So never 100% certainty, but we can get more and more certainty with more and more observations. The second type of reasoning is deductive reasoning, or deduction, and we could say that this gives us deduced facts. Again, things we haven't observed, but we believe they're true because we've used deductive reasoning to come up with them. You will remember that deductive reasoning interprets individual specific facts or observations, which we can call the minor premise, by combining it with a general concept, what we can call the major premise, in order to derive some more specific facts, what we'll call the conclusions, that we didn't know simply through observation. So we looked at the idea, for example, of making one observation or a couple of observations about a dinosaur tooth, and from that knowing something about the hip structure and the eating habits and the walking habits of the dinosaurs that we haven't actually observed. Note that this also is a way of extending our senses, because again, it allows us to know facts, in this case deduced facts, that we haven't observed. So again, we know, for example, that if a dinosaur tooth is thin and peg-like, we know that that dinosaur's hip had its pubic bone pointing forward, even though we haven't actually observed the pubic bone of that dinosaur. So the pubic bone pointing forward is a deduced fact rather than an empirical fact. However, we also saw that there's a problem with deductive reasoning, and that is that conclusions are only certain if the deductive argument is both sound, meaning that all the premises are correct, but also valid, meaning that the argument is arranged in such a way that the conclusion follows logically from the premises. For example, we talked about the idea that affirming the antecedent in order to prove the consequent is valid. What this involves is making an argument that if X is true, then Y must also be true. If Leo is a lion, then Leo has claws. And then you affirm the antecedent, yes, X is true, or yes, Leo is a lion. Therefore, you know with certainty that the consequent must also be true. If Leo is a lion, then Leo does have claws. Yes, Leo is a lion, and therefore you know that Leo has claws. But the big problem we talked about for science is that in a lot of cases where we're interested, we cannot observe the antecedent, the phenomenon where we want to know about. It might be too small, like an atom. It might be too far away, like a distant galaxy. It might be separated from us physically, like the center of the Earth. It might be separated from us by time, like the Big Bang. Those are all the antecedents. We can't observe those things directly. And so we can't affirm the antecedent, which would be logically correct. The only thing we can affirm or deny is the consequent, the results of this phenomenon that we can't observe. But affirming the consequent is logically invalid. If X is true, then Y must also be true. If we affirm the consequent, yes, Y is true, that doesn't prove that X is true. So if Leo is a lion, then Leo has claws. Yes, Leo has claws does not prove with any certainty that Leo is a lion, because Leo could be a bird or a bear or some other creature with claws. And so we actually have, from an argument like that, we really have no certainty to the conclusion. And if we're constantly relying on this in science because we have to, because we can only observe the consequence to affirm them, then we have a big problem. And I left you with that question, does that mean that science is all a sham? Well, it isn't. The solution is what we'll look at in the next video.